Okay, welcome to our video about oxidation numbers or states. You're going to hear that both of those words when referring to what we're talking about today. Oxidation number, oxidation state. Now what's important to understand about these is they don't mean anything physically. They're a system that was put into place so we could keep track of where electrons are going, all right? Once we start talking about redox reactions, this is going to make sense, but right now we're just going to do oxidation numbers and states. And there's 4 different rules for this. There are several more, but we're going to focus on these 4. These are the main ones. The first one is an element in its elemental state has an oxidation number of 0. So if we're talking about copper metal, zinc metal, anything like that, the oxidation number is 0. Number 2, ions. If you have a single atom ion like Cl- or Na+, the oxidation number equals the charge, which means the oxidation number can be plus or minus. So what's the oxidation number for K+? Plus 1. What's the oxidation number for S- 2? -2. All right? 3 and 4 are key as well. 3, oxygen is always -2, and 4, hydrogen is always +1. Those are going to play roles in how we determine the oxidation numbers of other elements, which brings us over here to some examples that we're going to do. So the first one I got up here is KCl. When I write the oxidation states, I'm going to write them underneath the element. If you look at different things online, you may see them written above the element, but it's the same thing. I write it below so I don't confuse it with charge. So potassium chloride, KCl. This is an ionic compound, and so it's going to have 2 different ions. What's the charge of potassium as an ion? +1. If we go back to rule 2, ions, their oxidation number equals their charge. So potassium is going to have an oxidation number +1. Chlorine, as an ion, has a charge of -1. So its oxidation number is going to be -1. There we go. Next we have oxygen gas, O2. This is oxygen in its elemental state. Because it's in its elemental state, we get 0. That was easy. Anytime you see something in its elemental state, its oxidation number is 0. Here we go. CH4. All right, this is methane. We have nothing here in the rules describing what we should do with carbon, but we do have a rule describing hydrogen, and that's always +1. So if hydrogen's +1, all the oxidation states are going to add up to the charge of the compound. So what's the charge of methane? It's 0. So what we're going to do now is we need to figure out what the oxidation number of carbon has to be in order for the whole thing to be 0. And in this case, the oxidation number for carbon is going to be -4. And the reason for that is you have 4 +1 hydrogens. So you need a -4 carbon in order to cancel out the charge, or excuse me, cancel out the oxidation. Here, KMnO4, well, we know potassium is an ion here. And so that charge is +1 because we know potassium is an ion, it's charge +1. We know oxygen is always -2, all right? Now figuring out the oxidation number for manganese is going to take a little bit of work, but it's very easy algebra. Everything needs to add up to 0. We have 4 -2s, so that gives us a total negative, like grand total of -8. We have 1 +1, so now we're at -7, which means manganese has to have an oxidation number of +7. If we move on to manganese 4 dioxide, we know oxygen is always -2. All right, and there's 2 oxygens, so that gives us -4, which means manganese has to be +4. You can see that manganese, the element manganese, has the ability to have several different oxidation numbers. You're going to see that in all sorts of elements. The only 2 elements that we're going to worry about that have the same one all the time are oxygen and hydrogen. That's it. So here, carbon dioxide, oxygen's -2, so we get a -2 in there, so carbon has to be +4. Again, you can see carbon has 2 different oxidation states, not a problem with that. H2SO4, we know hydrogen's +1, oxygen's -2, all right? So in this case, it's going to take a minute, but we get -8 over here, we get +2 over here, so our grand total is -6. This must be +6 in order to make sure the overall charge of this compound is 0, all right? SO2, we have -2 on oxygen, and we have to have a +4 on sulfur. And finally, SO3, we have -2 on the oxygen, and we have a plus 6 on the sulfur. This is how you find oxidation numbers. If you need any more practice, you can look up virtually any compound. The only ones that are going to prove difficult are organic compounds, because as you grow them, different carbons have different oxidation numbers. If you're curious about that, you can come ask me. But this is how we find the oxidation numbers for different compounds.